Okay, so here we are on problems number 33 and 34. For problem set 14, these are dealing with geometric sequences. We're adding an infinite number of terms. So the first thing we need is this, that the absolute value of r, sorry, not a, the absolute value of r must be less than 1. That is, r must be between -1 and +1. So right down here in this first example, I see my r is 1.3, so this is not going to have a sum. So there's going to be no sum. And the reason is, think about it. We're taking the number 2, we're multiplying it by 1.3, multiplying it by 1.3 again and again and again and again and again. That value is just going to get larger and larger and larger. And if I multiply by infinitely many 1.3s, then the sum is going to be infinity. Okay? And the term we use for that is we can say that it diverges. It never actually achieves a particular sum. So I can take either of these examples you have. So in these other examples, I have an r of 0.3, I have an r of 0.75 and 0.75, so these should have sums. Now, if I take a look at my previous sum, when it was I equals 1 to n of a1 times r to the I minus 1, here n was a finite number, and so we would get a times, or a1 times 1 minus r to the n over 1 minus r. But now, when we're looking at a sum that is infinite, then this r to the n, if we're taking a number smaller than 1 and raising it to the, and we can't, but we can think about it, to the infinity power, this value right here ends up going to 0. So our formula just actually becomes a little bit easier to use. It's just a1 times 1 on the numerator over 1 minus r. So we're looking at this first example here. We're taking 2 and we're multiplying it by 3/10, then multiplying that by 3/10, that by 3/10, and we're adding up all of those terms. Then in this case here, as long as I is 1 and we have an I minus 1 up here, then this is just going to be 2 times 1 over 1 minus 0.3, and I already did the work. We get 2.857 when we do that. Okay. Over here, again, we're already set up in our form. I is 1. We have to the I minus 1 power, so this is just going to be 5 times 1 over 1 minus 0.75. Again, already did the work, threw that into a calculator. If you want, 1 minus 3/4 gives us 1/4. 1 divided by 1/4 is 4. 5 times 4 is 20. And so what I did is, I'll show you just briefly here. I did these values out starting with 2, multiplying by 0.3 gives me 0.6. Multiplied by 0.3 again, I get 0.18. And I did a bunch of terms. I ended up doing 522 terms in this. And I added them up using the sum feature in Excel, and I got the 2.857. Over here, first term was 5. Multiplying it by 0.75 gave me 3.75. Again and again and again. And you can see when we sum them that we get 20. All right. So then what about this last one? Well, the question is, what happens when this becomes 0 and or this becomes I? A lot of times what you're going to find is it happens together, and it's actually easier than what I think I've led some of you to believe, in part due to the fact I was trying to get you to understand what the summation actually means. But I want us to think about this for just a second. If I is 0, the first term is going to have a 0 exponent, which becomes 1, times 5 is 5. So we're taking 5, and then we're adding, and then I would plug in 1. So this is 5 times 0.75 to the first, plus on and on and on. Well, if I go back to this example here, and I plug 1 in first, 1 minus 1 would give me 0. I end up, if you can see, I end up getting exactly the same thing over here. So we actually can say that this is equal to I equals 1, where the exponent becomes I take away 1. Now, If this was some finite number, we would have to adjust it. But because, and only because this is infinite, we can leave that as infinity. So in this case here, I would get exactly the same sum that we had in the previous example, because again, we're starting with our first term being 5 and going on from there. So I think I told some of you before that we have to adjust this value and adjust this value. That's true if it's a finite sum, not true if it's an infinite sum. Right? So hopefully that helps with questions number 33 and 34.